Okay, so this is going to be the next lesson on logarithms. We'll be looking at properties of logarithms. Like I said on Friday, just to recall, the inverse of an exponential function, for example, 10 raised to the x, would be a log. So the inverse would be log base 10 of x. So when we work with properties of logarithms, we'll see there's a lot of similarity with the properties of exponents. So it's best to review a couple properties of exponents. So let's begin with what we learned last trimester. If I have a base raised to some exponent and I multiply that by the same base raised to an exponent, when you multiply powers, to recall, you add the exponents. So b raised to the x times b raised to the y will equal b raised to the x plus y. So for example, 2 to the third times 2 to the fourth, and that would equal 2 to the 3 plus 4, which would equal 2 to the 7th. So notice though here, multiplication of powers involves addition of exponents. And you'll see logarithms kind of work the same way, except it's just a tad different. Okay, so now let's work with logs. So let's assume that we have log base b of x. Into that we're going to add log base b of y. So notice here I'm adding logs. Well, in adding logs and thinking about inverses, what operation do you think would result excuse me, when we add logs? Okay, well here's a hint. When we multiply powers, we added the exponents. So when we add logs, we'll probably have something that involves multiplication, and we do. So we say that log base b of x plus log base b of y equals log base b of x times y. Okay? So we have this property, which is on page 5112, and it says that log base b of m times n is equal to log base b of m plus log base b of n. So notice again, so multiplication ends up involving addition, just like we had with exponents. When we multiplied powers, we added the exponents. So key property of logarithms. We call that the product property. The product property of logarithms. Okay? Product involving multiplication but resulting in addition. Just like multiplying powers required us to add the exponents. Okay, so again, multiplication involves addition. So let's get just a little bit of practice with this property here. Let's say here I had log base 4 of 2, and to that I add log base 4 of 32. Now keep in mind, we can only add logs if we have the same base. Just like with exponents, you can only multiply or add the exponents for powers if you had the same base. Okay, so this would equal log base 4, so we'd have to multiply the 2 and the 32. So 2 times 32, which would equal log base 4 of 64. Now, log base 4 of 64 equals 3 because 4 to the third is equal to 64. So I'll run through several examples here and you guys will be required to do some work. Let's do another example. So let's say here I have log base 5 of 625. Into that I add log base 5 of 25. Well, this is going to require me using my calculator because I do not know what this is going to be offhand. But in any event, this will be log base 5 of 625 times 25. And 625 times 25 would equal log base 5 of 15625. Now, I would know that right offhand, but I'll take a shortcut here. Rather than evaluating that, I'll just go ahead and evaluate each of these. Okay, because that will be just a little different. Okay, so I can take 5 raised to the 5, or 5 raised to the 4. Okay, so log base 5 of 625 is equal to 4. All I did was just take my calculator and take 5 and raise it to the 4th. Got 625. And then plus, well, log base 5 of 25. That's easy. So log base 5 of 25, well, that's easy to do, and that's 2. Okay, so 4 plus 2 is 6. Okay, so that means then that this should equal 6. Well, let me just check. 5 raised to 6. So I'll do that with my calculator. 5 raised to 6. And voila, it does. So 15625. So as you're doing these problems, if you get a multiplication like we did here, and it seems somewhat difficult to figure it out, go back to where you started. It makes, sometimes it's just a little easier to do. Okay, let's take a look at another example here. If I had a log base 1/3 of 27 plus log base 1/3 of 1/9. Okay, so this would equal log base 1/3. Oops, let me write that a little better. Of 27 times 1/9, and that would equal log base 1/3, and 27 divided by 9, that would be 3. Okay, so log base 1/3 of 3, well, that would equal -1, because 1/3 raised to -1 is equal to 3. Likewise, we could have done each of these separately. Log base 1/3 of 27. Well, let's see here. That would equal log base 1/3 of 27. That would equal -3. And then log base 1/3 of 1/9, so that would equal 2. And then -3 plus 2 would equal -1. So again, you get the same answer. -1, -1. Okay, and just a couple more of those, so let's see here. And then we'll go on to the other property of logs. So the last example will be this here. So let's say here I have log base 2 of 10. Into that I'll add log base 2 of 12.8. Pause the video and see if you can figure that out. and then come back. Well, this would equal log base 2 of 10 times 12.8, which would be log base 2 of 128. Okay. Now, there's no way do I know what log base 2 of 12.8 is. And I don't even know what log base 2 of 10. But I will be able to figure out what log base 2 of 128 is. And all I have to do is with my calculator, take 2 and raise it, well, let's see, to the 6 is going to be 64, so that tells me that would be 7, 2 raised to 7. So this will equal 7. Alright, and maybe in just another example. So another example, so if I had log base 4 of 8 plus log base 4 of 2, that would equal log base 4 of 8 times 2, which would equal log base 4 of 16, which would equal 2. Now this I could have done, although you may not have been able to, but we'll look at this, or we'll learn about this when we get to exponents and radicals, okay, which will come probably in trimester 3. All right. So log base 4 of 8. Okay, so let's see here. What would that be? And we'll learn this. This would be 4 raised to the 3/2. I believe, however, we probably even looked at this first trimester, so that would be the same as the square root of 4 raised to 3. Okay, because square root of 4 is 2 and 2 to the third is 8. Yes, we did learn this in first trimester. And then log base 4 of 2, well, that would be 4 raised to the 1/2. Okay, which would give me 2. So here I would have 3/2 plus 1/2, and that would give me 4/2, and that would give me 2. Okay, so this would have equaled 3/2, and this would have equaled 1/2, and 3/2 plus 1/2 is 4/2, and that's the answer I got, 2. So actually, I guess we could have done this one, but you would have had to recall from last trimester. That 4 raised to 3/2 is the same as the square root of 4 raised to the third, and then a 4 raised to the 1/2 is the square root of 4, which is 2. All right. So for homework then, and get ready for the next video because we'll go over the next property of logarithms. But for homework, I want you to do this here. So let's take a look. Sorry about not being right at the correct page, but I was looking at another page, so I want you guys to do on page 516, page 516, 1 through 3, and then 20 through 22, and then we'll go on, we'll do the next property. So stay tuned for the next video.